All right, class, welcome to section 8.3. We are going to still solve systems of equations. As you see, I didn't leave myself too much room because these ones we're going to solve using matrices and our graphing calculators. So again, this being a graphing calculator based class, we can use some of the tools that the graphing calculator offers us. So I actually grabbed a few of the problems that we have solved in the previous sections. You might recognize some of these systems, and I'm going to show you how we could solve them using our graphing calculators. So for that, I'm going to backtrack just for a tiny bit to the systems we have solved in 8.1 and 8.2. So as you see, what we had constantly been paying attention to are the coefficients of our variables. So for example, we're looking right here at these two equations and we're thinking, okay, x has a 1 in front, this one has a 5, so I'm going to multiply this one by a -5 to get the opposite of it. And when I add them, I'm going to get 0 x's, so that means x is gone. And we keep doing that and looking at the coefficients, multiplying by whatever it takes to create these 0 y's, right? 0 variables. So basically, by making x have a 0 coefficient, that means it's not in the equation anymore, right? Same thing happens here with the y. So the point of this being that it looks like what we keep concentrating on are the coefficients of these variables, right? The x, y, and z just come along so we can keep it organized and we know, okay, the x's are in the first place, the y's are here. When I add them together, I'm going to get this many z's. So one method that would allow us not to have to keep writing the x's, keep writing the y's, are the matrices. So a matrix can serve as a device for representing and solving a system of equations. Okay, so what we do is we extract the coefficients of the variables and the constants. By constants, I mean the 43 and the -1, right? And these become the entries of a matrix. So we don't really necessarily need to know what a matrix really, the whole proper definition. A matrix is actually an array, a rectangular array of numbers. But what we're going to do is simply extract the coefficients. Be very careful, though, that if these variables are mixed around, that you know to rearrange them. So in other words, this is what I mean. I'm going to write a 1, an 8, a 3, and a -2. So when I write that, same as when I write an ordered pair, if I write 2, 7, I know for sure without having to specify that 2 stands for x and y stands for y, because they do always have to come in this order. So same thing here. If I write the numbers in a matrix, I should be able to safely know that right here are the coefficients of the x in each equation, and right here are the coefficients of y in each equation, right? So that's what I'm saying. If they're mixed around, you have to rearrange them. Then we're going to put a bar, which is where the equals are going to be. And then we put 43 and -1 across the equal. And then we don't actually need to go through all the steps on paper because, as I said, we do have graphing calculators to do this for us. But what we're doing normally, or what we would do on paper if we didn't have graphing calculators, we'd be working with these coefficients. So in other words, I would multiply this one by a -3 so that when I add it down below, that 3 is going to go away. But we'll let our graphing calculators do the work for us. So the point is, here is equation 1. Its coefficients. Here's equations 2's coefficients. The bar is where the equal sign is. And now we're going to take this very nicely and put it in our graphing calculator. Let me just do here this for a second. I just want to have this in front of me. Should have been ready, because as soon as I move over to the graphing calculator, I won't know any coefficients. So I will pull this up in front of me so I could see them as well. So let me show you what we do. Here's the graphing calculator. Now, on a graphing calculator, you see matrix right under math, but it's a second button, so second matrix. And maybe there's some already in there that you have edited, and maybe not. All you have to do is just, I had started to enter a few. I'm going to go to B, nope, okay, go back to second matrix, edit. Okay, so you have to go to the right and then edit, because what we want to do is we want to edit a matrix. And then you can choose whichever one you have on your calculator. Again, there might be nothing. I'm going to go to B. Now, a matrix comes with rows and columns. A row that's what I wanted. These are the rows, right? And these are the columns. So if I count, I see I have 2 rows because I had 2 equations, yes? And I see 3 columns, one for x, one for y, and one for the constant terms, okay? So I want to edit a 2 by 3 matrix, 2 rows, 3 columns, which I already have up here. So as you see, I have this already edited. Now, I'm going to go down there and I'm going to start writing my numbers. So 1, move over. As soon as you press enter, it goes over. 8, enter. 43, enter. And see how it takes me now to the second row, first column. I have a 3, a -2, and then a -1. Okay, so I've entered right there the augmented matrix to the system we're trying to solve. Okay, and then we have to exit from here. And now we have to go back to matrix. And see how in the middle it says math? This is what we want to do. We want to operate on this matrix. So what you will choose is RREF. And I put that in the notes as well. So I'm going to go here and I'm going to choose RREF. So row reference. Okay. Now I put everything in matrix B. So it's a little bit of a lot of going back and forth, but that's just how the calculator works. So you have to go to names and then you're going to choose B because that's where we put our numbers in. So here it is. I want to row reduce matrix B, press enter. So see how it gave me already a new matrix? I'm going to write that down. So by using this in the graphing calculator, I see these numbers. Okay. Now, be mindful, this is still where the equal signs would go. So if we kind of backtrack and think backwards, what would be the equations of this matrix here? These are the x's, these are the y's, there's the equal sign, and that's the number behind the equal. Well, my equations will say 1x, right, plus 0y equals to 3. However, what is 1x plus 0y? That's the same thing as just x. So that 0 there basically means, not basically, but it means that there is no y left in that first equation, and x is 3. Oh, there's my answer. The second equation says 0x plus 1y, right? That's the coefficient of x, that's 0. That's the coefficient of y, that's 1. There's the equal sign, equals to 5. Well, same thing, 0x is 0 plus 1y, that just makes it y. So what actually happens is that right here behind the equal, or behind this bar, we already have the two solutions to our system. So the solution's going to be the point of coordinates 3, 5. We didn't have to multiply, add, combine like terms, anything. The calculator did everything for us. Okay, let's try it again and again and again. So this is what I'm saying. I can't take the numbers as they are. I have to rearrange my system to get the x's, the y's in a line. And now we're good. So I'm adding 3x over to this side of the equals so that I can have them nicely lined up. Now the augmented matrix to this system is going to be 3, 1, 2, 3, 4, -1. And here is the bar. You don't have to write this, but one more time I'm reminding you so you can verify. These are the coefficients of x. They're nicely lined up. Coefficients of y, nicely lined up. The equal sign, nicely lined up. 2 and -1. So, let's go back to, one more time, second matrix. We want to, well, that wasn't good. I had to hit edit first. So second matrix, hit edit. Then you can choose B. Okay, so if you look back to your system, you will see that you still have a 2 by 3 matrix. In other words, 2 rows because of the 2 equations and the 3 columns. So let's go back here and start editing it. So I have 3, enter, 1, enter, 2, enter, then 3, 4, and -1. Okay. So I've entered again, as you see, the coefficients for the system. That's the augmented matrix I wrote for you down. Now I have to get out of here. So I'm quitting that and I'm going back to matrices. And this time I want to do math. So I want to do an operation RREF. And then go back to matrix. Choose names. So B, that's where I put all of that. And press enter. So here it is. So again, as you see, if I point out the numbers behind here, the last 2 numbers, those are the solutions to the system. Okay. But I write the matrix one more time. So you would have to write this on a test. 1, 0, 1, 0, 1, -1. And here it is. That means 1x equals to 1, 1y equals to -1. Therefore, the solution to the system is the point of coordinates 1, -1. Right? So I guess we're ready to upgrade to a 3 by 3 system, which if you've done the homework on 8.2, it does take a little while to solve. So here it is. I have this in front of me. I'm going to edit this. So I'm going to go to second matrix. So see how matrix, here, I'll write it down first. Here is our augmented matrix. And then I'm going to enter it. So here it is. I have 1, 1, -4, bar, -4. 5, -3, -2, 0. 2, 6, 7, 30. So this is what we call the augmented matrix. And as you see very nicely, all the x's are lined up, all the y's are lined up, all the z's are lined up, the equal sign, and then the numbers behind the equal, nicely in order. Okay. All right. So I'm going to take this matrix. Now, how many rows do we have? Let's count, because if you don't have the correct dimension, you'll run out of numbers, out of spaces. So your calculator will ask you how many spaces do you need for me to reserve for you. So we have 3 rows. 1, 2, 3, 4 columns. Okay. So now I'm going to a 3 by 4, 3 rows, 4 columns matrix. Oops, Well, that wasn't it again. Don't get too excited. You have to hit edit first. Then you can grab A. So as you see, matrix A has number of rows 3, number of columns 4, and now I can start going and typing in the numbers. So I have 1, enter, 1, enter, -4, enter, -4. See, now it takes me to the second equation. 5, -3, -2, 0. Whoops. Yeah, okay, yes, we're good. Then 2, 6, 7, and 30. Okay. So there's no space on the calculator for the whole thing, but I'm giving it another glance to make sure I type everything correctly. So far, so good. The first column, yes. Okay, so go back to second matrix, and this time do math. And now we have to grab the name, but first of all, grab the row ref. Oops. Well, see, if I didn't, what happens is I had to completely exit, and that's not what I was doing. Because the graphing calculator is still highlighted at 30, so it thinks that you still want to edit that number. So you really have to press the quit button before you start over. So yes, I am just as impatient and want to get on, but the calculator unfortunately stops me. So I want to hit math, row ref, now we're out of there. And it was matrix A where I placed everything. So I'm going back to A, here's the name of it, and now I can grab it. Enter, boom, done. So write this down. I have it. We've reduced it. And this is what you see. And same thing, behind that bar are the solutions to the system. So what are the solutions? The first equation here, again, if I copy it back, these are my x, y, and z. It says 1x, 0y, 0z equals to 2. That means x is 2. The second equation says 0x, 1y, so y, plus 0z, no z's left, equals to 2. And the last equation, no x, no y, but 1z equals to 2. So therefore, just as I've said, the solution to the system is right behind the bar. And this probably is the first system that I solved for you in 8.2. Okay. So let's try this again. Let's write down the augmented matrix. Okay. And now we're going to take this and plug it in. So here's my graphing calculator again. Second matrix. We want to edit matrix A, which is a 3 by 4 again. So I'm starting right here where it's highlighted. And I start typing in the numbers 2, -1, 1, 8, 1, -2, 3, 11, 2, 3, -1, and -6. Okay. Again, second quit, get out of here. Second matrix, go to math, choose row ref. Okay. And now go back to second matrix, choose the name A. This is where we had it. Okay. And here's our answer. What's the answer? It's right there behind all those 1, 0, 0. So the last column gives you the solution, which is 2, -3, and 1. I'll write it out though. So the solution was 2, -3, and 1. And again, I remember solving this system with you guys. So 1, 0, 0, 2. 0, 1, 0, -3, 0, 0, 1, 1. So here it is. 1x is 2, 1y is -3, 1z equals 2, 1. Okay. So remember these two systems. So let's go back. First of all, let's write the augmented matrix. 1, -2, -12, -41. 1, -3, -17, -59. 0. See how there's no x in here? So that means we have to put in 0. You can't just skip over it. Your calculator's not going to like it. Matrix is a rectangular array of numbers, so everything has to be filled in. The fact that there was no x there means that there's already 0 of them. Okay, so that's what we have to enter. Second matrix, edit. A 3 by 4 matrix. Okay, start typing. 1, -2, -12, -41. What happened? Well, I wasn't in the right place. It's a 3 by 4 matrix. 3, 4. Okay, so I have to press enter. I'm learning. Then it gives me everything I want. 3 rows, as you see, and 4 columns. Okay, now I can start typing. It's highlighting where you're supposed to be at. 1, oops, no, I want 1. Yes. -2, -12, -41. Well, I'm glad I'm making all the mistakes. So you could see I'm just as impatient and want to go on, but the calculator won't let me. Wants it very specific, and it wants enter every time. So 0 here, -2, -10, and 20. All right, now I have them all. Remember, you have to do second quit, get out of here. Second matrix, do the math, row ref, go back to second matrix, grab A, because that's what we were reducing. Okay. So, as you see, this matrix here is not as pretty with 1s and 0s in the first place. So, let me see if I can copy it down. This is what we got. We got a 1, 0, -2, 1, 0, 1, 5, something, 0, 1, 5, 0, and 0, 0, 0, 1. Well, that's kind of a little different. So let's see if we can write our equations. The first equation says 1x minus 2y equals to 1. So I'm not left with just an x, because not everything is 0 behind that. There's a 1x, no y, but -2z's, I'm sorry. Okay. The second equation says no x, but 1y plus 5z equals to 0. And the last equation here says what? 0 plus 0 plus 0, 0x, 0y, and 0z equals to 1. Well, all of this is one big 0. And one big 0 cannot equal to 1. Okay, 0 cannot equal to 1. So, again, look back. We have solved this system in 8.2. And what we concluded is there is no solution. And there's no solution is because this last equation makes no sense. This last equation has all zeros before the equal and then a 1 behind the equal. So 0 of anything equals to 1. That's not possible, so therefore no solution. Okay. All right, here's one more. So let me write the augmented matrix first. 1, 3, -1, 2, -2, -6, 2, -4, 2, -1, -2, and 8. And again, we've done this problem in 8.2. And I'm going to go next and enter it. So I want to edit matrix A, which already is a 3 by 4. And here are the coefficients. 1, 3, -1, 2. Jumps to row 2, -2, -6, 2, -4. Jumps to row 3, 2, -1, -2, 8. Okay, get out of here. Second matrix, math, row ref, back to second matrix. For names, grab the name of matrix A. Okay, so again, you kind of see some things going on there, but what I want you to notice is the last row of this matrix. And what you see in the last row is a bunch of zeros. So I will write it down. And I saw some numbers there, which really make no difference. Oops. Because all we're going to say is, based on this last equation here, I get a 0 of everything equals to 0. So basically the whole equation got deleted. There's no information there. I already know that 0 equals to 0. And so therefore this system will have infinitely many solutions. Okay. So now that we don't actually need to spend any time on solving the systems, I wanted to solve a couple word problems that will take us time setting up the problem, but we will need much time solving it. So it says, at a competing cupcake store, $4,520 worth of cupcakes are sold daily. The chocolate cupcakes cost $225 and the red velvet cupcakes cost $1.25. If the total number of cupcakes sold per day is 2,200, how many of each flavor are sold each day? So each flavor means chocolate cupcake. So we want to know how many chocolate cupcakes are sold. And then we want to know how many red velvet cupcakes are sold. Okay. And we want to see if we can represent this in an equation. So number of cupcakes, number of cupcakes, number of cupcakes. So x plus y will have to equal to 2,200. So whatever kinds we're selling, we have a total of 2,200 sold each day. So whatever many of each we have, together they have to add up to 2,200. Then we got to follow the dollars. So the chocolate cupcakes cost $2.25 each. So $2.25 times whatever many you're selling, plus $1.75 for each red velvet, times how many you're selling. So again, sell 10 chocolate cupcakes, you're going to make $22.50, right? Sell 10 red velvet cupcakes, you're going to make $175 times 10, so $17.50. The point is, we're going to sell a lot more than 10 because altogether the store makes $4,520. Okay. So we're just going to row ref this matrix. And what is the matrix? It's going to be 1, 1, 2200, 2.25, 1.75, and 45.20. So this is the matrix we're going to type. So second matrix, edit, and we're going to choose a 2 by 3. So what we had was 1, 1, 2200. Then 2.25, 1.75, and then behind the equal we have 4520. Okay, so we've entered everything in our matrix. Now get out of here and go back to second matrix math, row ref, go back to second matrix for names, and we wanted to row ref B. And here it is, 1, 0, 1, 3, 4, 0. And then 0, 1, and then 860. Okay, so that means what? X equals to 1340, and we've defined X as the number of chocolate cupcakes. The second equation says 1Y equals to 860, and we already defined Y, so we don't actually have to write it out again. In other words, write the answers, because we see that X is the number of chocolate cupcakes, and we see that Y is the number of red velvet cupcakes, so you don't need to tell the story twice. It's in the words already. Okay. All right, let's set one more up. It says a bag of mixed nuts contains cashews, pistachio, and almonds. So I'm going to go back to the question because I want to start writing equations. So it says how many of each type of nuts. So our nuts are cashews. So the number of cashews will be our X. The number of pistachios will be our Y. And the number of almonds will be our Z. Okay. So it says originally there were 900 nuts in the bag. Well, I'm guessing X plus Y plus Z were 900 done. Okay. 30% of the almonds, 20% of the cashews, and 10% of the pistachios were eaten. And now there are 770 nuts left. Now, if 30% of the almonds, and this is very nicely mixed up for you so that you can get super confused. It says 30% of the almonds were eaten. So if 30% were eaten, how much are left? Yes, because we now know what is left, not what was eaten, right? So you can subtract though, but here I'm going to do this. So if 30% of the almonds were eaten, that means we're left with 70% of them. 70% is 0.70 of the almonds were Z. 20% of the cashews were eaten, so we're left with 80% of the cashews, and cashews were X. And 10% of the pistachios were eaten, so we're left with 90% of Y. Okay. So this is what's left. 80% of cashews, 90% of pistachios, and 70% of the almonds. Originally, there were 100 more cashews than almonds. So the cashews were 100 more than the almonds. Okay, so this was our third equation. So originally there are 100 more cashews than almonds. So the cashews were 100 more than the almonds. Now, to enter this in the calculator, we have to rearrange this equation. So I need to minus the z over and have it equal to 100. So I'm minusing the z because I want all variables to be on one side of the equation and just the constants over to the other side. So here is the matrix that I need to enter. Now, hopefully I remember the story. So first things first, go to second matrix, edit, and it's going to be a 3x4 matrix. Well, the first one was easy, 1, 1, 1, and then 900, right? The next one, if I remember correctly, is going to be 0.8 or 0.80, right? I'm going to double check 0.9, what was left of the pistachios, and 0.7 of the almonds, and then 770. So let me make sure, 0.8, 0.9, 0.7, and 770. And the last equation here, as you see, is x minus z is 100. That means what? 1, 0, -1 is 100. Okay, so we had 1x, no y in this equation, in this story, -1z, yes, and then equals to 100. Okay, so let's get out of here one more time. Go to math. Ooh, I don't think I did it. I don't think I properly quit. No. So, yep, go to math, row ref, go back to matrix, and grab the name for A. Okay. And here are the answers: 200, 600, 100. X is 200, Y is 600, Z is 100. So if you add them up, you'll get 900. As you see, X is 100 more than Z. So again, these are easy equations to verify. And so at least the calculator takes a lot off of our hands. Okay.